Hi everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Specialist Mathematics Exam 1, the Northern Hemisphere. And yeah, so let's smash through this video. Like always guys, before I start this video, if you guys want private tutoring in Specialist Mathematics, mathematical methods, physics or chemistry, you can always email me through this email. And yeah, let's smash through this exam. Question 1. A 5 kilogram mass on a smooth plane inclined at 30 degrees is held in equilibrium. So anything that's held in equilibrium, we know that the acceleration is 0. By a horizontal force of magnitude p newtons as shown in the diagram. On the diagram above, show all the forces acting on the mass and label them. Okay. Alright, you should guys straight away know that there's going to be a gravitational force. And well, how much is it? It's 5 kilograms, so it'll be 5g. There will also be a normal reaction force. That goes like this. And we call that F of n. So a normal reaction force. And pretty much that's it. That's acting on the mass right now. And yeah, that's nice and easy. Find P. So, okay. Alright. We can see that this is a right angled triangle, but that's not going to help us. What can we do? Well, okay. We know that when we break down this vector, this weight, and we break it down to its components, what do we know? Just nicely. If I bring this over here, oops. Just bring this all over here. Okay. If I break it down, what do we see? Well, this goes down, and this one goes to the left. Okay. And what about if I break this down? What about if I break down the P? So like this. To a right angle triangle and goes, to this way and this way. Can you see how this one is parallel to this one? And now this one over here is parallel to this one. But I think I'm going to be using this one because if I use this one, I also have to include the Fn, which I have no idea what that is. So yeah, I would this one and this one. Now, of course, we're going to take down as positive. Okay. So if I was doing this, what do we do? Well, this one over here is what? This one over here is, I know this angle here is 30 degrees. So this, because of this, so it must be... this must be 5g sine. 30 degrees is pi on 6. That, and this one over here is what? I know also by symmetry this has to be 30 degrees. So this is p cos pi on 6. So I know that these are equal to each other because they are in equilibrium. So I can say that 5g sine pi on 6 must equal to p cos pi on 6. Okay, so, alright. So 5g sine pi on 6 is a half. And cos pi on 6 is root 3 over 2. So this will become 5g over 2. And this becomes, root 3p over 2. Now, these twos can just cancel out anyway, so it'll just become 5g equals root 3p. Hence, your final answer is p equals 5g root 3, or it can be rationalized to 5 root 3 g over 3. So, both answers is your value of p. Done. That's nice. Next question. So the next question, let me do it with this color. Okay, find a given that this dx equals this, where a is between -2 and 4. Okay, should always see this. I know for a fact I'm going to have to use partial fractions. So okay, let's break down this into partial fractions. I know that this a, it will become a over this over here. I can just rewrite it as 4 minus x, 4 plus x. Yes. So I'm going to partial fraction this, so it'll be a 4 minus x plus b 4 plus x. And I want to find a and b, so it will be 8a 4 plus x plus b 4 minus x. So in expanding this, we get 4a plus a of x plus 4b minus b of x. So a is equal to a minus b in terms of x plus 4a plus 4b. Now, by equity, we know that a minus b is 0, because there's nothing in terms of 0x here. So we can say that is 0. And I know that 4a plus 4b must equal to 8. So a plus b is 2. So if I bring these two equations over here and add them together, those b's cancel out. So if those b's cancel out, we get 2a equals 2, hence a is equal to 1. Now I know a equals 1 now, so let's sub it into one of these equations to get b. So we know that b is written as 2 minus a in this equation. So b in this equation is just 1. So, okay, b is 1. So this whole expression can be written now 8 over 16 minus x squared can be written as 1 over 4 minus x plus 1 over 4 plus x. Now let's integrate that. So integrate from negative 2a of 1 over 4 minus x plus 1 over 4 plus x dx. And alright, so that will be negative, so negative log e absolute value of 4 minus x plus log e absolute 4 plus x from a to negative 2. Now, we know a is between negative 2 to 4, so we don't even have to worry about the absolute values because, you know, these values over here, if you sub into any of these, it's always going to result in a positive. Is that right? So 4 minus, yes, that works. Yeah, they both, you know, result in positive. So we can just get rid of those absolute values. So right now we won't, because let's try to first sub those in. No, let's do it now. So 4 plus 4 minus x plus log e. Wait. Let's actually sub that in first. Let's sub those values of a. So it'll be negative log e a minus x. 4 minus a plus log e 4 plus a. That minus negative log e of 6 plus log e of 2, close bracket. So simplifying this whole expression gives us, now it makes sense. So because a is between negative 2 to 4, these over here, we don't have to worry about those absolute values. So we can just rewrite this whole expression as negative log e 4 minus a plus log e 4 plus a. Rewrite this as plus log e 6 minus log e 2. And so we get log e 4 plus a 4 minus a. Is that right? Yes. Plus log e 3. 6 divided by 2 is 3, yeah. And then multiply those, we just get log e 4 plus a over 4 minus a. And we know this whole expression equals log e of 6. Now, by equal to, so the inside is just 4 plus a over 4 minus a equals 6, which is just, those 3 can just get out of there, so it will just become 4 plus a, 2 or minus a. So 4 plus a, 8, minus 2a, 3a over 4, so a is 4 over 3. That's your answer. Nice. Yep, so that's good. Find the gradient of the curve of the equation this when x is equal to 1 over, give your answer in the form. So straight away, I know I'm going to have to use some implicit differentiation because it's in terms of y. So let's do this. Okay. Well, I need to find the y term, actually. Well, let's find actually the implicit differentiation. So what we're going to say is we're going to multiply everything by d dx everywhere. So this will be x equals d dx sine y over 15. That's it. So this will become 1. And this will become 1 over 15 cos y over 15 dy dx, because it's in terms of y. We derived it in terms of y. Perfect. So we need to get the y term now. So I need to find, when we let x equals 1 over 4 into this equation, what is the y term? Let's find out. So we want to find 1 over 4 is equal to sine y over 15. Now, okay, think of this y over 15 as an angle. So if I was drawing a right angle triangle, for example, so this angle here is y over 15, and this is opposite over hypotenuse, so it will be 1, 4, so this one has to be 15. So yep, 16 minus 1, yep. And so here we just want to find cos y over 15, so we want to find the cosine, so it's root 15 over 4, the adjacent over the hypotenuse, so we can rewrite this as 1 over 15 and root 15 over 4 dy dx. So simplifying this much further, becomes 60 dy dx. Hence dy dx is what? It's just 60 root 15, which is, rationalizing that, we get 60 root 15 over 15. Yeah, and that can be much simplified. So how many 15s can go into that? Will be 4. So 4 over 15, pretty much. 4 over 15 is your answer. Nice. Is everything right? Find the gradient. Yes, in terms of the form 4 over 15, where a and b are positive integers. Great. Okay, question 4 is with this card. Find the values of a and b given that z minus this is a factor of this equation where a and b are real constant. So that's not too bad. So well, if these are both constants, I know the complex conjugate root theorem applies here. So if this is a factor, I know for a fact that what's the solution? It's just 1 plus I. Yes. Is it? 1 plus I? Yep. So by the conjugate root theorem, so we know also this is a solution by conjugate, right, nicely, conjugate root theorem. Okay, so if these two are actual solutions, so what about if we just transform them into factors? So it'll be z minus 1 minus I, and the other one is just z minus 1 plus I. And we kind of expand those. Let's expand those. So if I was expanding those, it was z squared minus z plus zi minus z plus 1 minus I minus zi plus I and minus I squared, which is just plus 1. Okay, we get this, and if we simplify that much further, let's see if we can cancel some stuff. So z squared minus 2z. These cancel out. These cancel out. And we just get left with plus 2. So we get this beautiful equation over here. And I know for a fact that to get something like this, we can see that the final term and the ending term, for example, if we put when we start, it'll be z times something to get this, which is just z. So this has to be z. And this 2 times something at the end gives us 4, which would be what? -2. Just by having a look at that, yes, I've already seen those, and yeah, they fit in the description. Now, if I just expand this and then equate this to these values, I should actually find those a and b values. So let's do that. So I will do that with a different color. Let's go with this color. So expanding that will be z to the power 3 minus 2z squared minus 2z squared plus 4z. Have I done anything right? I just want to make sure. Minus 2z squared, yes. Plus 4z. Okay, perfect. So plus 2z minus 4. And so that's nearly done. So it'll be z3 minus 4z squared plus 6z minus 4. And by equity, it should equate to this, which is z to the power 3 a plus b z squared plus b squared minus a z minus 4, which will give us a plus b is -4, and b squared minus 4 equals minus a, actually equals 6. So now I know these two. If I had these two, luckily those a's cancel out, so it'll be b squared plus b. 6 minus 3 will be 2, so b squared plus b minus 2 equals 0. And can we factor these out? So 2 to 1. If I put it here, 2. 1 minus 2, negative, so it has to be here, which is 2 minus 1. Yes, 1. So perfect. So if I now, this will become b plus 2 and b minus 1 equals 0, which is therefore b -2 and b equals 1. So we have two values of b. Yes, it says find the values of a and b. Now we have two values of b. Now, for example, let's take the value of b equals 1 and sub it into this one over here. So we find the value of a. So a minus 4 minus b. So a is what? If I put b, so when a is equal to -5, b is equal to 1. When b is equal to -2, let's try that also. Minus -2, so -4 plus 2. 2 minus 4 is -2. So a equals -2. Have I done anything wrong here? 2 minus 4. Looks good, actually. So that's good. So done with that. So here are your two values of b. Right over here. So let's make everything smaller so it does fit in. Done. So there we go. Perfect. If I'm even, so -4 minus 1 and -4 minus 1, 2 minus 4, 2. Perfect. Question 5. Part of the graph of this is shown. Find the volume generated if the region bounded by the graph of this and the line x equals -1 and half, and the x is rotated about the x-axis. So, okay, so imagine this over here. If I was just drawing it nicely. So it looks like this right now. Imagine just reflecting it, and we are rotating along the x-axis, so it will look like this. So if I was rotating this, I know the formula is going to be v is equal to pi, the integral from, because it's dx, in terms of dx, because we're rotating about the x-axis, and we know that we're rotating from -half to a half, and we have to have y squared. What is y squared? It's just squaring this over here, which is going to leave us with x plus 1 over the square root of 1 minus x squared. Now, of course, we can't integrate this. I mean, if you let u equal that, no, it doesn't work, because we have the x plus 1 here. So what I'm going to think is we separate it. So if we separate this, so so if we separate this, so -half x over 1 minus x squared plus 1 over 1 minus x squared dx. Now this is easy, because I know this one over here is a sine, inverse of sine to integrate this, and this one over here, now we can use u substitution. So yeah, let's do that. So this would be, the integral. What's this one? Okay, let's bring it here. X over 1 minus x squared. If I let u equal 1 minus x squared, dx is going to be 1 over the derivative of this, which is -2x du. So this whole expression can be written as x over 1 over u times -half x du. Those x's cancel out, leaving us pretty much with a -half square root u. If I'm not saying, yeah, so -half square root u. So that's just okay. So we got there. Leave us with, yeah, so negative, we can write it as u to the -half to make convention much easier, over 2. Okay, now differentiating this, integrating this, it's going to be bring that -half and just integrate this. So it'll be u, if I add 1, will be half, and divided by a half. If I divide it by half, it's just going to be 2. So imagine 2 square root u, pretty much. So it'll be 2 square root u. Yeah, so yep. So, and those cancel out, we're leaving us with -u. So pretty much -u, which is, what's u again? 1 minus x squared. So that will just leave us with -1. So negative square root of 1 minus x squared. Plus, now let's integrate the other one, which is very nice and easy, because it is just going to be a inverse of sine. So we sine inverse of x from -half to a half. And we're gonna, don't forget that pi here. Am I forgetting anything? Nah. So let's bring this over here. Bring this on top and integrate it nicely. So let's do that. It's going to be pi. Okay, if I sub in a half, it'll be negative square root 1 minus a half, just 1 over 4, which is this will become root 3 over 2, plus sine of a half, which should be pi on 6. So sine inverse of a half inside is pi on 6. Yes, pi on 6. Minus, if I put this, it should still be negative root 3, because it's going to be that negative half is going to be squared anyway. And if I put it in the inverse of sine, I get minus pi on 6. So we get this, so pi, see if I cancel some stuff out, so minus root 3 on 2, plus pi on 6, plus root 3 on 2, plus pi on 6. Which gives us pi on 3. those two add up, leaving us with pi squared over 3 units cubed. That's nice. Question 6. Find the real solutions of tan to x equals negative tan of x. Nice and easy. I know for a fact that this, I'm just going to simplify it by using the double angle formula. So I know that this over here just becomes 2 tan of x. This is in your formula sheet. 1 minus tan squared of x is equal to negative tan of x. I'm just going to bring this over here, so it'll become 2 tan of x equals negative tan of x 1 minus tan squared of x. So 2 tan of x, negative tan of x plus tan squared of x, or tan cubed actually, tan cubed of x. So so negative tan of x plus tan cubed of x. And so what we're going to do now is bring that 3 tan x over here equals tan cubed of x. So tan cubed of x minus 3 tan of x should equal 0. So if I can take tan of x, tan squared of x minus 3 equals 0. Well, you can see that we have tan of x equals 0, and also tan of x equals plus or negative root 3. So let's have a look at this first solution over here. If I was drawing tan of x equals 0, what is this general solution? Well, imagine drawing the tan function. Now we know, okay, it's going to look like this. It's going to have like that. Like that. So when does it equal 0? Well, if this here is pi and this is 0, it's always going to be 2 pi here, and it's going to look like this. And so it's always going by pi pretty much. So we can rewrite that as x is just going to be 2, actually pi n actually, pi n. So what? Yes, it's going to go by pi. So yeah, pi n, where n is an element of all integers. So before writing, so we just want to write that where n is an element of all integers. What about the other ones? So let's look at the positive version first. So tan x plus root 3. When is tan positive? Tan's positive over here and over here. I know this angle here is pi on 3. I also know that this angle is pi on 3. So if I'm going to, like, what general solution? Well, if I have pi on 3 plus pi n, does that work? So for example, if I sub in n equals 0 plus pi on 3, perfect. What about if I sub in 1? It'll be pi, then we add pi on 3. Yes, we also get to this. What about 2 pi? So 2 pi is over here plus pi on 3. Yes, again, so that works. So pi n plus pi on 3 is an actual for that one. So x equals pi n plus pi on 3, where n is an element of all integers. Let's try the other one, which is negative. When is tan negative? Well, it's going to be over here and here, but this is again pi on 3, and this over here is pi on 3. So it will be here, it will be pi n, but minus pi on 3, is that right? So if I sub in 0, it'll be here. If I sub in 1, it'll be pi minus pi on 3. Okay, yeah, works also. So pi n minus pi on 3, where n is an element of all integers. These are your values, your solutions. Nice. Perfect. Let's go down. Question 7. Let dy dx be this. Okay, express y in terms of x. Okay, so it's a differential equation. I know I'm going to use separation variable because it's in terms of y. So, okay, I know for a fact that, okay, if I write this as, okay, dy dx is 4 minus y squared multiplied by 1. And why do I write that multiply? Because that's in terms of x. I want it in terms of x. So if I'm going to integrate this thing in terms of y, I'm going to do 1 over it. So it'll be 4 minus y squared dy equals the integral of this one over here, which would be 1 dx in terms of x. So let's do that. So it'll be the integral of 4 minus y negative 2 dy equals the integral of 1 dx. This will be what? 1 over, if I add 1 to this over here, it'll be negative 1. And derive this, it'll be negative 1. 4 minus y, negative 1. And this one here will be just x plus c. Pretty much leaving us with 1 over 4 minus y, x plus c. Now, we know our initial condition states that when x is 0, we know that by this initial condition, we know that when x is 0, y is equal to 3, so it'll be 1 over 1 c, so c is actually just 1. Hence, just 1 over 4 minus y equals x plus 1, so solving that, that'll be 1 over x plus 1, 4 minus y, hence y is 4 minus x plus 1. That's it. Done. That was nice and not too bad. Express d squared y dx squared in terms of y. I know for a fact that this is going to be using what do we call implicit differentiation. So d dt of what we have here, which is dy dx. So d dx actually of dy dx, and what's dy dx of this whole thing? We also want a d dx 4 minus y squared this. Okay, so this will simplify to d squared y dx squared. Alright, so I know for a fact that if I bring that 2 in, multiply by the derivative of the inside, 4 minus y minus 1 from the power, and then I have to multiply by dy dx because it was all in terms of y. That gives me negative 2 4 minus y dy dx. And I know that dy dx is this over here. So let's write that down. Negative 2 4 minus y squared. So dy dx is 4, pretty much 4 minus y squared, which gives us negative 2 4 minus y to the power of 3. Hence, your final answer is d squared dx squared negative 2 4 minus y to the power of 3. Let's put that there. In terms of y. Perfect. Question 8. A 3 kilogram mass has a velocity of this, where v is equal to this. When it has a displacement of x meters from the origin, x is greater than 0, find the net force Newton acting on the mass. Nice and typical question. So we know that the net force is equal to the max times acceleration, so we need the acceleration. Well, it's v in terms of x, so I know for the best way I would say is using, we know acceleration is going to be v dv dx, so I'm going to use this formula. So I need to find dv dx. So dv dx is just going to be the integral, to integrate this. So how do I do that? Well, I have to, because it has a lot of expressions, so I'm just going to write it. So v is what? 2 tan inverse of root x. I'm going to use the chain rule. So I'm going to let u equal root x, and I'm not going to let phi equal 2 tan of u. U dash is just 1 over 2 root x. V dash is 2 over 1 plus u squared. Multiplying these two together, what do we get? These cancel out. Hence, we can say 1 over square root 1 plus u squared. And what's u again? U is this, to imagine squaring that, so it will just be x. So we can rub that over here and just say 1 plus x. So, okay, we just integrated pretty much dv dx here. So integrating dv dx, we get this nice expression. That over here, and we get this is for dv dx. We also want to multiply it by v, so v is what? 2 tan inverse of root x over root x 1 plus x, and done. So that's your acceleration right here. Now, we have acceleration, we just multiply by the mass, and that gives us the force. So your force is going to be 3 times, so we just 6 tan inverse of root x over root x 1 plus x. Not too bad. Kind of rubbed a lot of the, what do you call, like the working out? Yeah, but it's all right. It's question 8. So I hope you understood that question, how to do that. Question 9. Around the variable x and y are independent variables where for x this is the mean, variance is that, for y is that and that. The variable z is such that this is that. Find the, okay, not too bad. So if I want to find the expected value of z, it's going to be the expected value of 2x plus 3y, which is just the expected value, well, it's in your formula, it's just 2 expected value of x plus 3 expected value of y, which hence is just 2 of 4 plus 3 of 3, so it'll be 8 plus 9, 17. Find the standard deviation of z. So to find that, I'm going to use, okay, we need to find the variance of z first, which is the variance of z of 2x plus 3y, which is 4 variance. The constants get actually squared, so variance of x, plus 9 variance of y. So what's the variance of x? We know the variance of x is 36 plus 9. What's the variance of y? Which is 25. This is going to give us, so what's 36 for? 6, 12, 18, 24. 24, 4, 8, 12, 12, 13, 14. So 144, pretty much. 144 plus, what's 25, 9? 25, 9, 45, 18, 225. So 225, leaving us with 369. So we have this, and we just take the square root of 369, and that should give us our actual standard deviation. So your SD of z, square root of 369, which is, okay, I can see that 9 can go into it. So how much 9? So what's 369 to 9? 4. 41. So 341. Can 41 be also? Nope, it doesn't go. Verse 8. Researchers have reason to believe that the mean of x has decreased. They collect a random sample of 64 observations of x and find that the sample mean is this. So it's been decreased. State the null hypothesis and the alternative hypothesis that should be used to test this mean as this, has been decreased. So we write the null hypothesis. We're stating that there's no change. So your mu is just going to be 4. Yes, of x. And your alternative hypothesis, we're saying that the null, it's actually decreased. It's less than 4. Let's see. Calculate the mean and the standard deviation of the distribution of the sample mean for the samples of 64. Okay, you should know, okay, calculating the expected value for a sample mean, it's just a normal sample. No, it's the normal mean of the actual original which is just 4. But the standard deviation of the sample mean is written as square root of n. So your what is your standard deviation for in terms of x is 36. So we're saying 36, the square root of 36 is 6. So we're saying 6 square root of 64, which is just 8 actually. Write it like that. Just 3 over 4. That's it. Those are the mean and standard deviation for the sample. That's easy. How long? How many questions? Okay, 2 more questions. Consider the vectors a and b. Find the value of c, for which c is an element of all reals, if the angle between a and b is pi on 3. Alright, so I know for a fact that, okay, a dot b should equal to the magnitude of a times the magnitude of b times the cos theta between those angles, the actual angle, which is pi on 3 for this example. So a dot b, what's a dot b? Well, a dot b in this case is negative 2, negative 2c plus 3. So 1 minus 2c. What's the magnitude of a? It's 1 plus 4 plus 9, which is square root 14. What's the magnitude of b? It's 4 plus c squared plus 1, so the square root of 5 plus c squared. Okay, now putting those all together, we get 1 minus 2c. Multiplying the square root, we just get 14, 5 plus c squared. And what's cos of pi on 3? Which is a half, actually. So half multiplied by half. If I can just change this to 4c, we get rid of that half anyway. So let's do that. Square root both sides. So if I square root this, we get this. So 2 minus 4c, 2 minus 4c. Taking like wait. What do I just take a 2 out? So if I take it, it'll be 4. 1 minus 2c is equal to 14, 5 plus c squared. This is 2, this is 7. So 2 minus 4c, 35. Alright. Plus 7c squared. So therefore 7c squared. No, I'm not too sure I've done this right. Wait. I've just made I made it too complicated. Alright. Let's just simplify this. 2 minus 4c. 2 minus 4c is 4. Minus 8c. Minus 8c plus 16 squared. So it will be 4 minus 16c plus 16c squared is equal to 14 times 5. What's 14? 5? It's 20. 5, 6, 7, so 70. So 70 plus 14c squared. That's much nicer. So it will become 2c squared if I bring it minus 70. Minus 70 minus 16c plus 4 equals 0. So 2c squared minus 16c. Minus 70 plus 4, it's going to be minus 60. 66, yeah? Is that right? Yes, equals 0. Take that 2 because a common factor from all of them. We get c squared minus 8c minus 33 equals 0. I'm just going to use complete the square for this one. So c squared minus 8c. So a divided by 2 squared. What's that? Plus 16 minus 16 minus 33 equals 0. Hence, C is minus 4 squared minus 49 equals 0. Okay. Hence, we can say C minus 4 is equal to plus or negative 7. C is just 4 plus or negative 7. So we get two values of C. We get C 4 minus, which is negative 3. 4 minus 7, which is negative 3. And C is equal to 11. Now, okay, we need to be careful because it says find the value of C, not two values. So how do we find them out? Okay, there's this property of a dot product. Okay, if we're saying, if the angle that we're saying is pi on 3, wait, this is what I want to talk about. If the angle is between 0 and pi over 2, A dot B must be greater than 0. If the angle is between pi, not pi, less or equal to pi on 2, A dot B must be less than 0. So this is a property that we should use to find out which value of C we should take. For example, we're using pi on 3. Now, pi on 3 is between this, so we want the A dot B to the dot product to be greater than 0. Let's try to solve that. So we know A dot B is 1 minus 2C. So let's write 1 minus 2C greater than 0, which gives us negative 2C greater than negative 1. So C is less than a half. So C must be less than a half. Which one is C must be less than a half? It's that C equals negative 3. So absolutely we should take C equals negative 3 as our answer. Done. Question 11. Find the length of the curve specified parametrically by x equals this and y equals that from this to that. Okay, this is nice and easy. We know that to find our length of a parametric equation, we know we're saying from 2 pi on 3 to 2 pi, and we know it's just the square root of, well, in this case, it's just going to be dx d theta squared plus dy d theta squared in terms of d theta. So what's dx d theta? Let's find those. Actually, let's write this expression, 2 pi on 3, 2 pi. Okay, what's dx d theta? Well, dx d theta is going to be a minus a cos theta. Is that right? Double checking it. Yeah, that's good. And we imagine squaring it, we get a minus a cos squared. And yeah, so we get this. And let's actually just square it. Should we? Yeah, let's try to square it. So if we're saying this, a minus a cos theta, we get a squared minus a squared cos theta minus a squared cos theta plus a squared cos squared theta. So we get a squared minus 2a squared cos theta plus a squared cos squared theta. So let's write that down. So it'll be the square root of this whole big expression. A squared minus 2a squared cos theta plus a squared cos theta. And let's find the other one, which is dy dx squared. So let's try to do that one. Dy dx is what? It's going to be a sine theta. Yes. Yes, so squaring that, we're just going to get a squared sine squared theta. Now, because all of this is in terms of cos, so I just want this in terms of, because it's in terms of sine, it's a pain in the ass to deal with, so I know I'm just going to change it to 1 minus cos squared theta, this here. So it's just a squared minus a squared cos squared theta. Alright, so that's what I want to make sure to put now. So let's rub this whole thing out. And let's take this whole expression, bring it over here. let's continue this long. So it's going to be plus a squared minus a squared cos squared theta d theta. All right, that's it. So let's see if we can simplify some stuff. So, okay, we can cancel those out. Anything else? Okay, we can rewrite this whole expression as 2 pi on 3, 2 pi, square root, 2a squared. Now we can take those out. I'm only left with minus 2a squared cos theta d theta. Alright, so wow, we've actually gone through so much, and we're still doing. We can't really simplify this. Well, I mean, let's take that dA d theta. Let's just go down here. That, we can take that 2a, for example. Those 2a squared, we can take it as a common factor. Now, this one over here, I want it to be, like, for example, this one over here, I can rewrite this as, in terms of the double angle formulas. Like, if you remember, this 2x, we know that cos 2x is equal to 2 cos squared of x plus, I think it was minus 1, yeah, from the formula sheet. So, all right, in this case, we want, in terms of, squared. So, in our case, it's just, this is cos theta, and 2 cos squared theta on 2 minus 1. So we have cos theta plus 1 divided by 2. Wait, yeah, no, just be careful of that, actually. Yeah, pretty much we're saying this is what it is. This is your cos theta. So let's write that down here. Square root 2a squared 1 minus 2 cos squared theta over 2 plus 1. Those cancel out, that's good. So now we are left. Have I done anything wrong here? Any mistakes? Wow, it's such a long question. Cos theta is this. We've stated that. And what I've done is, just want to again reduce the whole thing here. This is very, okay. 2a squared 1 minus 2 cos squared theta over 2 plus 1. Yes. Okay, that leaves us with 2a squared 2 minus 2 cos squared theta over 2, which gives us 4a squared 1 minus cos squared theta over 2. Now this is just 2a, square root of 1 minus cos squared theta over 2. And we know this over here is just equal to sine squared theta over 2, which gives us 2a sine theta on 2. Wow. Okay. Makes sense. Okay, so 2a sine theta over 2. So this whole expression, I want to take that 2a out, actually. So it's this constant 2a, 2 pi on 3, 2 pi sine theta over 2. Sine theta on 2 d theta. Wow. Quite long. So, now let's integrate that. That's much easier to integrate. Let's integrate this. So it will be 2a integrate from, okay. So, wow. So, okay. 1 over a half negative cos theta over 2. 2 pi to 2 pi on 3. How many marks is this question? I really got 4 marks. Wow. So it'll be 2a negative 2 cos theta over 2, 2 pi on 3. So it'll be 2a negative 2 cos pi over 2. No, so cos pi, actually, just cos pi. Yes. Minus negative 2 cos pi on 3. So what's just cos pi on 3? Cos pi on 3 is a half. Half times 2 is 1, so it'll be negative 1 over here. It's 2a. This over here is negative 1, so it'll be 2 plus 1. So 3 times 2 is 6a. Wow. 6a. That's your final solution. Very, very long, I'm not going to lie, for a specific question. That took too long. 6a as your answer. Wow. I would say this question is quite very long. I think it should be like 6 marks, to be honest, for such question, because takes too long to really get this, like the formulas and all the stuff. So yeah, I would absolutely not, I didn't like this question. I found it very difficult, I'm not gonna lie, with the algebra and stuff, so that was a problem for me. I'm not too sure how other students went in this exam, but it was, I'm gonna rate it. The last question was very difficult, I'm not gonna lie, so that's what I can say. I'm not gonna lie, that was very hard. That I was scared that, you know, one algebraic mistakes can actually ruin the whole question for you. So yeah, that's, at least we can say we finished it. Hope that's right. I've got to check my answers after this video, so I hope that's right. 6a. Alright guys, thank you so guys for watching. Please make sure to like and subscribe for more videos. And yeah, take care of yourselves. Have a good day. Bye bye.